Gaetan, and hopefully this presentation will be a bit different. I am not a developer, but a librarian at the National University of Singapore. I am in charge of the digital scholarship team, where we work on showcasing our collections and the result of the research done at the university in a fun and interactive way. It's not all about books here, and today I am going to tell you about our map collection. Let's have a quick look at our site first. So we have a base map showing contemporary data from OpenStreetMap, and it's using all the standard gestures we know from using online maps. Here we have a list of maps that were digitized by our Department of Geography, and we can choose the maps we want to display. So let's have a look at this map from 1966, for instance. You can see that it was made of a few sheets of paper. Each one was georeferenced so that it would properly be layered on the geographical coordinates, and we stitched the result together for display. Singapore is a country that evolved really fast, so it's very interesting to compare the shape of the coast, for instance. Here you see that the whole Marina Bay area, which is very developed today with landmarks like Marina Bay Sands and Gardens by the Bay, actually sits on reclaimed land, and the area was covered with water in 1966. If we look at this map from 1974, we can see that the coast was already starting to change at the time. And if we go further to 1983, at the time we even had more development, and we can see we had infrastructure like roads and bridges that were already built. Now what I like the best is look at older maps. So we can look at 1914 here, and I really enjoy looking at how things looked like back in the past, and especially how places had different names. I think you can all see how valuable such a platform can be. Now, as librarians, of course, we are very focused on preserving our data and making it widely available and reusable to the general public. If you aren't familiar with geospatial data, you have to know it is a very peculiar beast to work with. This is a screenshot from QGIS, and you can see there are literally dozens of different competing formats. And you can see on this screenshot we have more formats than there are JavaScript frameworks to choose from. And we aren't even going to cover anything regarding projections or coordinate systems today, thankfully. The main issue we had here was that geospatial data can be quite difficult to manage. The usual stack for this kind of project involves a dedicated server running specific software like Map Server, and maybe even something like Map Proxy on top of it to speed up the retrieval of the image data. This meant a pretty heavy maintenance overhead for us, and so we designed a fully static architecture that does not require any of this. We transformed all our data in a format called Cloud Optimized GeoTIFFs that contains the whole tile pyramid of each layer, and our interface is using HTTP range requests to fetch the relevant parts of the image rather than the whole thing, which would be very slow. We use Astro to generate the web pages themselves, OpenLayers to manage the map, and Svelte helps us with the whole application logic and interface. Now what is so great about Svelte is that it is surprisingly close to JavaScript. It provides us everything we need to build a nice interface, but it will stay out of the way when we're using vanilla JavaScript libraries, which is perfect for someone like me. Since we needed to use cloud optimized GeoTIFFs for storing our data, we required a mapping library that works with them natively. This is how we chose OpenLayers to implement our map. Unfortunately, there is no pre-existing Svelte wrapper for OpenLayers. So let's have a look at how we created a handful of Svelte components to display an OpenLayers map. We chose to leverage the Context API, which allows us to weave things together. Svelte context is not reactive, but it will allow us to share an object with the children of our parent component, and in this object, we are going to have Svelte stores, which will bring reactivity to our application. Here is the file where we define how our context will be created, and you see the function will return an object with a handful of Svelte stores. Here, we are looking at the root component of our application. You see it accepts basic props to set the latitude, longitude, and zoom level of our map, and has two child components. One is the base map, and one is the interface. Let's have a deeper look at our OL map component. You see it uses the create map context function we defined, and this allows us to share reactive stores with the child components. Further down in this component, we use onMount, instantiate the map from open layers, and make it available to other components through the context. Here we are looking at the base map component. After getting the map instance from the context, it simply adds the OpenStreetMap layer to the map using basic features available in open layers. As you saw earlier, the other child component was the map interface itself. So this is the component that will be in charge of adding the other layers. To make things smoother, we are lazy loading the maps when the cursor goes over a link using Svelte features like the once modifier and the pointer enter event. And here, we use Svelte's conditional rendering to add the layer once we have detected this event. This was a quick overview of what we did for our project, but I hope it shows you how easy Svelte made it for librarians to code this platform. Thank you for your time, and I hope you will enjoy exploring our maps in our repository.